So obviously everybody knows this is about piping into PHP. Essentially what this talk is about is how you can send messages into a running PHP process. Particularly something that's running from the command line. So it's not actually something that you do from a website point of view, but rather a script that you're running from the command line. In our case, it's for a long-running script, and that's particularly why we want to be able to send messages into it. But I'll get to that. So we'll cover what and why. Streams, Unix pipelines, name pipes, and then eventually actually PHP, and then just go through a summary over there. So what and why? What? Send input to a running PHP process. We use name pipes, which are an extension of pipelines, which make use of streams. So this is all in the Unix architecture. Streams, pipelines, name pipe, and so on. We'll get to an explanation of each. Why? I looked at this as a way to solve a problem that we face at work. So we've got a long-running PHP script. Long-running in the sense that it runs all the time, 24/7, for days on end. And if it gets close to dying, then it restarts itself. So it's literally running continuously. So we've got no control over it once it's running. If we need to make code changes, we deploy code and then we literally just kill it by typing kill. Kill process ID and it dies, and then it restarts again either with a cron or by us starting it manually. We get no visibility on the process, so there's no way for us to go and say, print out or write a file, how far you are delayed and so on. So this is a very real-time kind of process. So if it starts falling behind, we get out-of-date information on our system, which then leads to financial loss on our side and so on. And growing needs. The initial implementation of this script was done in a very simplistic manner. It was done to get it to market so that we could actually start selling the product. So the growing needs is now that we have traders. So I work for Betting Gaming, which is a betting platform, sports betting, horse racing, and big casino integrations. And so we have traders that manage our clients' books, basically manage their risk. So our traders now, instead of having 1 and 2 and 3 clients, are managing a whole bunch of clients. So they need, when things do go wrong, or they suspect that something goes wrong, they need a much simpler interface to be able to basically get updates or make sure that things get settled and so on. So it's kind of growing needs that we have to look at, is giving them a bit more power so that we don't get called on the weekends and 10 o'clock at night when things are going wrong and so on. Streams. So we have the PHP, we're building up to that. Streams is, initially it started out as being your streams of data elements processed in order, so let's just take it that it's always sequential kind of thing. You get 3 standard streams, input, output, and error. So traditionally your keyboard was your input, so that was only input into the system initially. And that would be your standard in, obviously, input. Standard in goes into a program, and then the program can either have standard out or can go to standard error. Actually, there's a difference. There's a reason for the differentiation between output and the error. Come to that soon. I'm going a little bit too quickly. Unix pipelines. So streams and pipelines. What about code? We'll be looking at code soon. Pipelines. So a pipeline is basically chaining a whole bunch of processes together. And then what happens is that the output from one program becomes the input from another one. So I don't know how many of you guys work on Unix often and have done any kind of stuff on Linux. Okay. Not too. So I think, imagine most of you guys understand what pipelines are, how it works and so on. Okay, carry on in any case. So essentially what happens is that the output from one program is redirected into another program. So rather than just being displayed on the terminal, it gets done as input into the other one. And your standard error is still either, depending on if you are manually redirecting it or not, it gets displayed on the terminal. So you can run a whole bunch of processes, a whole bunch of programs, pipe them together, and if any errors happen in any of those programs, you'd have to see them in terminal. And that kind of junk wouldn't be passed into the next program. It would just get whatever was out. Okay, so everybody sees that. Standard out becomes a standard in, standard out becomes a standard in. And eventually when all the programs in the pipeline are finished, that standard out gets displayed in the terminal. Redirection, just going over what the previous one was. And that's output and errors can be redirected. So in that example, you saw that the output of the errors always went to the terminal, but you can still also redirect that. I'm not going to go too much into that because we're kind of doing a very high level thing to be able to actually get into the PHP stuff. Redirecting output to another program is how pipelines are built. So obviously we saw that from the diagram, and you can obviously also redirect your output or your errors into a file. Name pipes. So names, what frame or Bob. Actually you can name your pipe frame if you want to. You can name it Bob. So I see these as multi-use pipes. So traditionally the pipeline that you saw there, it exists anonymously and it only exists as long as the process is running. The name pipe persists while the system is running. And then you can name it so you can use it more than once, and you can delete it when it's no longer necessary. So your normal pipelines exist only as long as those processes are running. You can have no kind of interaction with them. And you can't send any further information or any further input than what is actually already running in this process. With name pipes, you'll basically create a name pipe or a FIFO buffer, and it will sit there, and then you'll be able to send input into that. And you'll be able to do that either from the keyboard, so from the terminal, or from a program redirecting input to that name pipe. So you can then reuse that multiple times. And whichever program is receiving the output from that pipe, that program could get restarted, you could attach another program to the pipe.
So when you set those up, do you set them up with the pipe and then the output to another process, right? And that just sits there, and then you can continually pipe stuff in and it always goes through to that same...
Yeah. So what you'll do is you'll basically, I'll show you an example, but in this case we just echo something into the pipe, and whatever program is started listening to the output of that pipe will get that directly input in. So it's almost as if you're pushing it into a file, and on the PHP side it sees it pretty much as a file.
I'm assuming, of course, that all pipes are at a very basic level of FIFO key.
You'll actually see with the creation of pipes, see that it's literally just a file. So there's also, as you can see, previous slide, particularly why I kept that thing of things processed in order. It's a sequential thing. So you'll write something to the pipe, and obviously if you haven't got anything listening on the other side, if it takes a while before it actually picks that up, it'll be blocking. And then you could write something from another terminal or whatever, and that would block as well. So the first one would go in, the second one would go in. Okay, working with name pipes, there's a couple of examples. I put these in the slides because typing while reading slides is not fun. So it's created with a MK5 command. There are other commands. This one worked for me. I'm not really genius or weird or anything, so that's what I know works. You get the pipe ready for input. So basically cat is concatenate, and the little arrow redirects it into our name pipe, which in this case is /10/PHP Cape Town. So that you can see you can name it anything you like. I put mine in TMP just because it's a temporary thing. And then the ampersand on the end just redirects out. Basically checks it as a background process. And then what you get on the next line, we can point over there, that's actually the process ID of that cat process running and sending any input into the pipe. Okay. Then you fire off a process to read from the pipe. So now you take concatenate cat and take whatever the output is from the pipe and pipe it into a script. And again, the ampersand to do it as a background process. We obviously do ours as a background process because we fire it off in the input. And then if you echo hello into your pipeline, it actually ends up into your process as input, as basically as a standard in. What I've done there is why I'm showing this thing over there, your little cursor that is blinking. What happens there is I haven't actually, so this one would have failed because it didn't actually exist. And there it's just sitting in this blocking basically. So you'll sit in the terminal, echo, whatever, and it goes into the pipe, but if nothing's picking up the messages, it'll just sit in and literally it seems like it's hanging, but it's just a blocking process.
Oh, so it queues, and then as soon as you attach something to it.
As soon as you attach it, it'll pick it up and carry it. Which I don't even get to the speed at which I'm running through these slides. I'll have time to actually demonstrate to you guys.
But the second command has already got the pipe open for writing.
Excuse me?
The second command, the cat,
Yes.
has already got the pipe open for writing.
Yes. So that's a little bit like Rudy to me. I don't understand exactly
I
why.
think-
But basically doing that keeps your pipeline
From
open.
sending an end of file through
Yes,
to the PHP. Yes.
Okay. That's my understanding. Anybody who wants to correct me? No? Okay. Okay, getting PHP to listen for input. So finally we actually get to PHP. And I have put very simplistic code here. Here's an example that I grabbed from the PHP.net itself. So you can either access it as an input stream with the built-in wrapper, that's obviously built into PHP. And then you see it just uses the fopen, which again, it sees your standard streams, standard input, standard output, standard error as files. So there we're just opening a fopen in a read-only mode. Obviously it's standard input, so any messages we get in, all we can do is read those. We can't send anything to standard input. And to actually get the contents of what's on that, use fgets, trim it, just to trim off the line ending and so on. And that would be what the line is. The recommended way, because apparently the wrapper is quite buggy in some versions of PHP, the recommended way is to use the constant, so that stdin actually is a constant which is an already opened and initialized standard input stream. So not only is it cleaner, but it's the recommended way to do it. So let's see some code. Here's a very simplistic one. I'll put this in a little function so that we can see how it is called in another slide. Important over here is to set your stream set locking to false. So that's essentially just saying whatever the standard input is, because obviously we can do it for error and whatever, set it to 0. So if it was blocking, let me get this straight. I may actually have this wrong. If it was blocking, basically your program would read a certain number of bytes till it fills up the buffer, and if it doesn't fill the buffer, it'll wait until more input comes in on the input stream. So if you don't get any further input, the program sits there, and unless you send more input via name pipe, the program's going to sit there and wait and wait and wait and wait. So it'll just sit in a tight little loop and not do anything. I've got a wrap up there and a little while thing, and it's just while it's not file in file, and gets the line as we saw earlier. If it's empty, it just breaks out. I do that so that we can call this periodically, and if nothing actually is sitting waiting for us on the standard input stream, we can just skip straight out and carry on processing. And then you just append it to 10. So we're going to be sending in text. It's always going to be 10. And then return whatever it is. So if either it breaks out because it's empty, we've reached the end, we're not really picking anything else off the stream, break out, return what we have. Okay. That makes sense? Nobody's asking a question? Okay, so what it's doing, which is exactly what I just did, set it to not blocking, loop over the stream itself, read from the stream, so that obviously goes and fetches the default number of bytes from the stream. If it's empty, break out, carry it on. So this is where we actually call that function, and you see right over there, that's where we call the function. I've got it in an infinite loop, so while 1 is equal to 1, I then go and I don't want to read from the standard input continuously, so I just go and have a little time lapse over there, and it'll read from it essentially every 11 seconds of the end. Reset it, read, exit, and so if we get a particular message that says stop, the script will exit. So in our case, that would allow us to send particular messages in, and then on the inside we would then go and take those messages and act on them depending on obviously what you coded into the program. So for some things, when we have an event that's not displaying on the website, so there's a soccer match that's not displaying on our client sites, we could get the traders, traders could basically click a button and it would send a message in here, and then we would go and then request that from our service provider. So there'd be no manual interaction. As it stands currently, they'll get a hold of us, and then somebody as a developer has to actually log in, start restarting stuff, shuffling things around, and then to actually get it to bring in whatever it's not bringing in. So the hope is, once this is implemented, we'd be able to give them an interface where they can literally just click and say this particular thing isn't coming in, maybe put in a particular ID, hit the button, it goes off, requests it, and then we start getting the information. We can also, when we deploy code, we can also send in a message that basically says restart. And then what it can do is we know that when we're restarting it, all database commits and transactions are done. We're safe in terms of the database, we're not going to corrupt anything, and then the script can fire itself off again and then kill the existing one. So I'm sure everybody knows, but once PHP script is running, it's loaded all of the files into memory, so you can go make as many changes as you want as long as that script's running. No changes are going to get affected in your code. So the only way to do that is to bring that script down, start it back up again, and then it loads those new files fresh into memory. So that's the reason we need to actually restart the feed anytime we make code changes. It's for it to actually bring in the new changes. Okay, we're happy with it. If we get any message in, we just echo it out. If we get nothing, and even if we do get something, we echo that. So there is the output. So in this particular one, I've just gone PHP process for PHP, and it goes and runs through. It's the 11th iteration. We get nothing off the stream. So if you go back and look at this time, even though we're getting nothing, so that would essentially be null or an empty string, because that's what we defaulted to. Let's all put the end of line. So that's why you see that little new line, empty line there in place. Because you didn't get anything to the stream, we still put an end of line, and then kicked over and reset it, so we can know that within the next 10, 11 seconds we'll basically read from the stream. So, all together now. This is basically all the commands that you run to set up your little FIFO buffer, your name pipe, whatever you want to call it. Like FIFO can null nothing into it, throw it in as a background process, and then echo something into your stream. And it's sitting waiting for something to start picking it up. Sitting waiting for something to pick it up from your name pipe. So, any guess to what happens? So we echo hello into the name pipe. So there's the output. It runs up until it hits the number of iterations, echoes out the message it got in with an end of line, and then resets the timer. So if we had left that, we would have gotten back up to 11, we would have gotten an empty line, and then I would have carried on, because you would only ever echoed one bit of input. Okay, everybody with me? Always worry when nobody asks questions. Nobody's asking questions. Okay, so will it stop? So obviously, I showed you in the code previously, if it finds that exact match on the string, stop, then what it should do is kill itself off, make a little message and so on. So we'll actually do this now with a live demonstration as well. So here we see we started, and it's reading from the name pipe. No other changes. It's number 11, echoes exiting done, and then it just sits there because we're still running the cat part of the pipe. So it doesn't actually exit. You're going to go Control C and that'll kill. Which is something I still have to figure out how to get around in production. Hope it's still good there. So in summary, what and why, obviously covered what we talk about and why particularly streams. You guys, most of you seem to know what streams are. Unix pipelines, main pipes, so all that stuff put together allows us to actually send messages into PHP and then we got our summary. Again, I've got some sources and some more sources. I'll put this up on Meetup, so you guys can have a look at that as well. And I finished ready for the time.
So I have a question for you.
Sure.
As I understand you to explain this by using the constant, using standard in, you've avoided the need to actually spell out PO.
Yeah, so that anytime your script starts up, that constant will already be initialized with whatever's coming from the standard input. So you only
file
store
handle, right? It's the file handle.
yeah, it's basically the file handle. So I only showed you the standard input, but you obviously the standard input, standard output, and standard error each have got their own constants, and that's a safer way. I'm not too sure why, but I know that some of all the versions of PHP will bug you with a particular output. So the constant is just a shortcut to get to the file handler that you need from the directory.
Now, there's an aspect of it that interests me here in the light of the example. You see, from my limited understanding of the processes involved over here, the PO appears to have the restriction that once you've used it, you can only read or write to that particular type. Now, do you not have that restriction when you're using the standard in, or is the fact that you use that interesting technique to put into that string a hello getting around that? Am I making sense?
Yeah, I think I understand. So what you're basically saying is, what it is that if you're referencing standard input, you can only ever read from it. You obviously won't be able to write from it. So that's a one-way in. And the standard output is obviously also a one-way out. You can only ever send messages out.
So is that the case?
Yes.
And you sort of seem to have sidestepped that with that interesting twist you have there, that you stop in between and you interject with a hello into the string.
Yeah, so periodically what that does is just picks up a message or whatever text it's received from the standard input and then acts on it, whatever you've managed to hard code or configure in the code and so on. But it's a one-way, so your standard input will come. And then if you look at it, it would help if it was actually on the screen here. So we're getting input to the standard input via the pipe. That's essentially sending a standard input. And what's being displayed here on the screen, is my understanding, is basically standard output.
But you see, if you go back to one of your screens before that, after your 10 iterations, you had a cat with that hello there, you see, between text 11 and text 1 again.
Okay. So this is basically going through the loop, sleeping for a little bit, and then as soon as it got to that point there, it actually called the function that picked up whatever was coming in from the standard input. And like I said, that's a read-only. You see with the wrapper, the wrapper, even though you put R for read, you could, imagine you could probably put anything there, it's still only going to be read-only. Even if you were to go and try and write something to that, I'm pretty sure just ignore it silent. I haven't tested that, but that's why I imagine it's PHP, it's just going to ignore it and carry on with nothing else. Okay.
And you prefer to use FO instead of the PO? Is there a reason for that?
It's not a process. It's
Ah.
a file.
Yeah, it's a file.
So
So even in Unix, if we had to go and it's going to do that.
It's only got real files in the files.
If you do LSL on there, you'll actually see that your permissions and stuff is different.
Oh, really? Okay.
Sure.
I wonder if you did like a cat on that file.
It'll show up under proc devices as well as a block device.
Okay.
That's a Mac, so it might not.
Yeah.
Yeah,
So this is running on changes. It sees it as. I can't remember the command, but it's a way to. I couldn't actually. Some of those didn't work when I sent those. There you can see essentially this sees it as a file.
Just
in terms
it's got
of
a P in
Unix
the front.
accessing it.
Yeah, it's got a P in the front of it there, but just do file on the file, just the command file on that. There you go.
There you go.
they figured it all out 40 years ago, man.
Yeah, yeah. That's the one thing that grabbed me about all of this is how old this stuff actually is. So we're looking at like the origins of Unix kind of stuff is when they actually thought this through. I can't remember the name of the guy that actually decided that streams, pipes, that kind of stuff, but it was origins.
Was it Richie?
I think it was Richard.
No, they
There
were
was C.
C guys.
Good.
Yes, the K1.
Right. Anyways, so some dude in the big beard decided this is happening. And he was right, it was really clever. Okay, so there you can see what I've done there is just basically prepped it, all that sort of stuff. And if we go and so you can see, because it's blocking, there's no process sitting on the other side waiting for the input. It sits there and it's just going to sit there indefinitely. We go and run. So yeah, it's still sitting, waiting for something to happen. I did that wrong. Thank you. And obviously the other one's running indefinitely as well.
Gonna park it on the other side.
Alright,
You need to park it on this side. Cancel that process.
Yes, thank you. If I had a prize, you would get it.
We're gonna rank one off.
Look at the
10 rings. Alright. You guys should have tested this before. Okay. Right. Should have put in a whole lot less than that. What's going on?
And like with echo something into it, right?
Now you know I'm looking out into the slides to begin with.
Do you mind putting the code up again? In the corner of the top.
So that's what you're saying, you have to do that.
Before you correct.
There you go.
Excellent.
There you go. Sitting ahead of all of my history. Shouldn't have been that bad then. Okay, so now we've echoed hello. There you go. Stop.
Well, that kills it. See? Kills the process on the left and
Yeah. And because we're still running the cat, we actually have to kill that. So I meant to show you first time, right? Thanks, Danny, for the help.
Couldn't you do something very cunning and once it recognized stop that you also finish by issuing F tools?
You sure?
F tools.
Probably good.
Underneath.
Given my fun example now, I'm not going to try to do that now. That's a very good idea. Yeah, probably could do something like that. So the initial example that I worked off of, that I seem to have lost the link to, so you basically cat, like we saw over there, you do that cat into there, and then what you can do is grab that process ID, write it out to file or something. So my thinking is, what we do what we have also, pick up whatever process ID you want. Now's not the time to think about that. But any person,
somebody wants to see the code again.
This meeting
code.
Because you can also do this in Bash. Or you can create file FIFOs and use them in the exact same manner. If you want to control processes and have like a long running.
Is that what you're looking for?
Yeah, let me just see if I've got it.
So once it's read that line, it clears it out of the stream.
Yeah. So as it's reading there, it picks it up off your input stream. Once it hits the empty part, there's nothing left, nothing left buffer, nothing in the input stream where it's out. And then in the PHP code, it looks obviously for the particular stuff. So what we do on our side is, you're only doing it periodically, but when we hit that point, there's no database transactions outstanding, there's no funny stuff happening. And if we issue like a restart, we can basically fire off another command line process to listen to that we pipe that stream into. And then it can just kill itself off. So, because it runs so long and PHP can have leaks, and obviously our code can have leaks as well, over time the memory usage builds up and doesn't decrease, even with garbage collection and so on. It grows. So we managed to get it to run for quite a number of days continuously without actually doing anything. We have a check, and again periodically we go and actually check what's the memory usage, and if we start getting too close to a maximum memory limit, fire up another process, kill the one we're in, and then it carries on running seamlessly. Which is a little bit hacky.
Just to restart it then?
Yeah. So we basically need this thing running constantly because there's matches, sports matches happening 24/7. So what we use this for is live in place. So literally when a soccer match kicks off and we want to bet on who the next goal scorer is, we'll do it right there and then. And that stuff changes, like we get gigs worth of data coming in. and we process it. It has to be basically real time. So if you're more than 60 seconds behind, our service provider basically kicks us off because it gets dangerous. Dangerous in the sense that guys can take bets on stuff, knowing what the outcome already is. So somebody scores a goal and he can take a bet on that. Obviously, when that happens, then our clients lose money, we lose money. So.
And the other half of the program, please? Thank you.
So you playing with it?
I do want to.
Making some improvements.
So the only thing I don't understand is the cat in the beginning. So if I'm understanding you correctly, you're basically running cat continually on that pipe, right? You're running it in the background. So you're creating a blocking. You're basically watching that file for changes, and then as soon as anything is inserted into that pipe, then it's going to cat it basically into the output.
That's my understanding of it. Yeah. I would have loved to have actually found the web page where I started on this weeks ago. I pulled off to do something else. I pulled off of that to do something else. So this is kind of one of those things that happened weeks ago, and been a work in progress, and I cannot find that link. But I actually did explain what that cat was doing. Can't find it. I'll keep trying to look for it, and then because I'm also curious, so help me, I can find it.
But it's slick because effectively it allows you to write something.
Yeah, so for our purposes, I would have used a JSON encoded string, because that would have allowed me to send to arrays and objects and that sort of stuff. So like I say, you've got a whole bunch of soccer matches. So let's just say our traders determine for whatever reason that they think on this particular soccer match there's match fixing happening. So what they want to do is want to basically take it off the site, but we also want to stop receiving the data for it, so we don't go and create new markers and so on as we get fresh data. And that would give them, they basically go next to where the soccer match is, hit a button, that would send a message to the program. It then picks up, here's a little JSON string, here's a particular ID, make the call to what we have is socket, so we're reading stuff off of the socket continuously. So then we'll basically write something onto that socket that says, stop sending us information for this match. And then they'll stop sending it to us, we'll stop processing it, free up some resources on our side. So that's one of the ideas that I had. Derek now.
Why not just use React? Then you've got a server, you can send messages to the server over curl from PHP.
Because React, we looked into it, and some of the stuff that we run doesn't work, it crashes.
Yeah, we
actually looked
did
into
have a
it.
look at React as a company, and people kind of decided on Node for our socket applications. Our socket as in WebSockets on clients, browser clients. So for this we obviously still use PHP because it's so tightly coupled with the rest of the system. I haven't actually, maybe we can chat afterwards and you can let me know how you see that working. I'm aware of adding a new service to something that already, as many of our clients are based in Africa and run a single server for the database for the website. So we've got PHP running, but we'll have Node on everybody running soon, and Elasticsearch, and what else do we run? Memcache, and then going and adding some other service that just feels like it's adding. And we already run Rabbit, I think. We run Rabbit. So there's a lot of stuff I'm not involved in. I'm like deep into the betting and trying to get this kind of stuff running smoothly and so on.
The other question is obviously why not just use a queue? Like Rabbit.
I did think about that. I mentioned this to Rudolph a while back. And, this is the talk I'm going to give, and he's like, why don't you just use a queue? So the thing is, I'm not too versed in using queues. Imagine it's a service, you make a call, there's latency, and any of that, I don't know how much latency, it's pretty wrong. I know that our latency writing to MySQL has actually caused us many headaches, and with Craig's help, I've managed to reduce our I/O usage on the disks, and then obviously what that does is reduces the round trip time between actually getting data, writing it to the database, getting something back. So we work in those kinds of things where 200 milliseconds, 20 milliseconds builds up over time, and then we start falling behind, and then bullshit breaks loose and that sort of stuff. Because then we run big whoppers of queries to take stuff off the website. We go and basically update a whole bunch of records so that you can't get them anymore. And queue is actually something I am going to research, because I did come into another stumbling block after you mentioned that to me previously. So when I look at queues, once I'm done with what I'm currently busy with, and then I think after that, then when I do actually get back to this, when I have a look at queues and see what kind of latency that adds. So currently I'm working on cutting down the number of queries we make, and the number of small queries that we make. So how it was written was literally in a kind of incremental fashion, just to get it to work. So we got it working, and then we had to start making it more efficient because we started getting more information. So in the early days, at the peak you have 20 matches live. Now you've got 120 matches live, and there's thousands of markets on each match. And for that, for each market, you'll have, like a soccer match, you've got home, draw, and away team, and also Man United, draw, Chelsea. We'll have thousands of that kind of stuff, and that's 24/7 that group. So any kind of backlog that we have builds up over time, and then we start suffering. And then, unfortunately, our busiest times are Friday nights, Saturday nights, Sunday nights. So during the weekend, at night, that's when things start falling over.
So did you go partying on a Tuesday?
Which ones did we see where the part was it Tuesdays or Wednesdays? I think it's Tuesdays or Wednesdays. But yeah, it would pretty much. It used to be that Mondays were quiet, but we offer, in terms of South Africa, we offer stuff that nobody else offers with that kind of software package. So we give you thousands of matches every month, where our competitors, if you go to a competitor's website, you'll see one match live, and then we'll have like 4 offerings on it. We'll have 120 matches live, and there'll be 500 or 1,000 offerings on that particular match that you can bet on. Who scores the next goal, turn corners, who has the next corner, correct score.
It's a huge amount of data.
It's insane.
Sounds cool.
And from their side, it's all mathematically driven. So they've got actuaries building mathematical modules, and they just pump us this extreme of information, and we try and parse it and fit it into our data structures that weren't designed to handle this kind of stuff. So this is a way that I was hoping to do that, and possibly a queue would work better. And then there's a few other things that I could probably use a queue for as well. So,
can you have like multiple pipes open, and then how do you differentiate on the reading side?
yes, that's actually something I made in my notes, but I kept just hitting it. So what happens is, once you've established that one pipe, that's a bit of a caveat. You've created your pipe. Now you write into this pipe. There can only be one thing listening to it. If you go and start off another process and take the contents of that pipe, it's going to go to your new process, and whatever your first process was isn't going to get anything on its standard input. So if you go and take the same pipe and put it into 2 different processes, one isn't going to get that info. As far as I understand, you can write from multiple places into the same pipe, but you can only read from one.
You can create fan apps where you create a listing of all the pipes you want, and then just iterate through that.
What you said. Grab it later and ask them. I think I've actually hit my time limit, but if anybody else has got any more questions, we're all happy.